Flashy news headlines advertising the possibility to see nature's own light show are commonplace in news and weather websites. These headlines often lead to a ton of disappointment. Maybe someone looked outside at night but saw no magical lights over their head. Or they forgot about it, went to sleep, and woke up to aurora photos from their state plastered all over social media. Regardless, the skies often do not meet the expectations set up by these headlines. Or maybe the skies lit up but gained no prior news coverage. Why is this, and how are the northern lights quote unquote forecasted? The field of forecasting northern lights and a select other phenomena related to it is called space weather. All parts of this field tie back to the star that keeps us all alive, the sun. The sun has a very large and chaotic magnetic field. Due to its turbulent nature, the sun's magnetic field lines are prone to snapping and releasing bursts of plasma and radiation out into the solar system. Luckily, Earth's own magnetic field protects us from these. Back to the sun, though. Magnetic field lines on the sun can meet and collect into condensed areas, which are known as sunspots. These areas are the sources of solar flares, the aforementioned bursts of radiation and potentially plasma. When the field lines snap, solar material can be ejected from the sun, and this is known as a coronal mass ejection, or CME. In the event that it's directed towards our planet, the CME travels through space and eventually impacts our magnetic field. When our magnetic field is hit by the CME, it compresses. This is called a geomagnetic storm. Charged particles from the CME interact with it, which excites these particles and causes them to light up. This light is the aurora. How exactly is this forecasted, though, and how do news outlets know what to report on? Forecasters track the time when a CME is released and use numerous different models to predict how it might impact Earth. Sources of error can come from many places. Chronograph imagery is the main source of imagery that is fed into models to make forecasts. However, this imagery is imperfect. It can have missing frames, show a lack of material when there is material, or other issues. Other unpredictable factors can also influence the trajectory of a CME, such as the Parker spiral, a spiral current of solar wind caused by the sun's rotation, material in the CME's path dragging it and slowing it down, or errors from a 3D event being fed into a 2D model. This can lead to CME travel times being much faster or slower than originally forecasted, never arriving at all, or being weaker than expected. Factors at Earth affect whether or not the northern lights will dance over your head as well. The BZ component of our interplanetary magnetic field, or the IMF, is one of the largest deciding factors. The CME comes with the magnetic cloud and it interacts with our own magnetic field. If the magnetic orientation of the portion of the CME interacting with Earth is southwards, then it will compress and connect with the magnetic field and cause a stronger geomagnetic storm. However, if the polarity is positive or northward, the CME's magnetic field will repel our own. This can lead to little or no geomagnetic storming even if we are hit by a strong CME. Luckily, most strong CMEs have at least some southern component. These are reasons why sometimes forecasted auroras simply never show up. However, these are not reasons to stop looking for the northern lights. Space weather forecasting is highly imperfect, but it's constantly improving due to the efforts of hardworking scientists. And the news isn't always wrong, it's just reporting on a topic that's much more complex than it's made out to be.